We're here on Twitch and maybe even YouTube. I keep forgetting to check YouTube, but we're streaming live with the Lift and Shift Foundation and our Battle of the Bots design team. It is Thursday night. We try to do this thing called the Steam Engine, where we do a little nerdy stuff. Most of the time, it involves our design team, and it's a peek behind the scenes at the things that we do to develop parts of our programs or projects that we're working on in general. And tonight we're going to build a robot because we need a second robot. So we're going to build one for Saturday's Battle of the Bots. We're going to get started here by doing that. So I've got some views set up. I've got some scenes set up. We're gonna crash my desk for the evening. We're gonna build this robot. I am not by myself, as I mentioned most times. I mentioned being part of the design team. I'm the founder of the Lift and Shift Foundation, but I'm also a team member on the design team, and it's kind of like cool. I just actually built a registration page today on our website, so that's going to make its way into our links on Twitch, on YouTube, wherever you, Instagram, Twitter, wherever you find us, that will end up in a link somewhere where people can sign up to find out more about the design team. Join us whether you're a veteran, a volunteer, an intern, a mentor, an engineer, a student. It doesn't really matter who or where. We're not really too picky about who is qualified because it's rather inclusive. But our design team kind of. The goal of our design team, the mission, the mandate, is to help promote and produce the Battle of the Bots program that we run as a nonprofit. And there's some other things that happen. We get some benefits when we can, like scholarships to classes or access to free websites and things that sponsors give us, so that we try to make sure that the design team gets first access to all of the resources that are provided to the nonprofit, and also our makerspace, which sometimes people, if you've seen any of these streams, you've seen me like shooting lasers off my 3D printer and stuff like that. That stuff is all available for our design team to take advantage of as a group and as a team. So when we 3D print things, I will print everybody's designs and mail them to them if it works out like that. We're sometimes building 3D printing new parts for the robots. We'll save that for another day though. And it's a group, but we're actually on a Zoom. So back to this stream and tonight and the group. I mentioned this design team. We're on a Zoom, and the Zoom is hidden right now. My desktop is logged in. That's actually my old phone is logged into our Zoom. And that's the view you see here. I'm sharing my webcam on Twitch instead of Zoom, but I do have another screen over there with Zoom on it, and our design team is there in the chat, and also wherever they feel comfortable getting in, whether it's here in the stream live on Twitch, whether it's a little more private in our Zoom group. That's how we kind of structured it so that everybody feels comfortable participating as a group, and I'm not leaving anyone out, because to me that's actually a very important part of the whole team word. But I like to teach, and I like to show people things. I like to say, hey, this is not something that we spent weeks preparing, because a lot of times things look hard and complicated, and they're not really. So many times I'm working on the fly, like no prep, no planning, or very little prep, very little planning, specifically because I want to show people that things in science, technology, high tech fields look complicated. It looks hard. It looks like things you can't do, but that is absolutely not the case. So I try to share everything I'm doing, not just from an educational standpoint, but also from the standpoint that, oh, look, it's not that hard. And one of the things I do is I'm getting in the habit of now is sharing how I set the stream up and how I do things. And we use Streamlabs app because they have a nonprofit plan. And part of the Streamlabs app, or service or software or whatever you want to call it, is a an app on my phone. So my phone right here, ooh, look at that. So my phone has the Streamlabs app, which is actually like a remote control. So I can control the stream from my phone, which means I can get rid of the keyboard. This keyboard here, which you can see on this everywhere else, is going to go away, so I can actually work on my desk. This is one of my favorite parts about this, but I'm going to show real quick. Where'd you go? There you go. Let's do it here. So here's the screen. I'm going to change views really quickly to the desktop view, and there it is right there. And I can change to the go back to my screen right there. So I'm gonna plop this down on the desk right here, and I'm gonna get rid of my keyboard, because that's the first step in working and building with things is I need space to do this. And what people don't know is I live in New York City. I'm in Manhattan. I live in a shoebox, so space is very, very important. And I'm gonna ditch the close-up of me, because as I get in and lean into my desk, it's gonna be awkward, and nobody really cares to be that close to my grill anyway. So let's dig right into a robot. How about that? Got a glass of water with a little bit of cranberry juice in it and a little bit of lemon, because lemon has a lot of electrolytes, and I'm training for another marathon, if you can see all the medals in the back. And there's another heat wave here. If you're out and you're doing things, drink water and eat things with like salts in them, electrolytes, magnesium, potassium. Eat bananas, lemon juice, those type of things, because they'll not only replenish the water in your body, but also the electrolytes that you don't realize you're losing, because you're sweating them out with the water, as it's what was it, like 93 here in New York City today. But let's switch gears, and let's take a peek at this guy right here. In fact, let's go big screen. pie, so that wasn't so bad. Here on the stream, the view, I'm just cramming all the bags into this box so I can throw it all in the recycling all at once. And we've got this battery, this AA battery pack that holds 4 batteries. But I have a AA battery, the 3.7 volt battery pack that I want to see like how it works in person. And what we're going to do next is we're going to plug this thing in. We're going to jump onto mBot, onto the block building software, and we're gonna plug this in. We're gonna test it, make sure it works, and we're gonna try out some things with some sensors. I have a second robot here that's already all built and one that we use, so that will be our test. In fact, let me check that robot box to see if we actually have extra parts. The battery pack that I wanted to use. I don't see it yet. Let's grab this remote out of the way and all of this other stuff and put it in my parts box. We will set my parts box aside. And I'm going to get out the fancy robot. Oh, here it is. We don't have to take a small break. I'm just gonna drop stuff. How about that? So check it out. Here we go. This is super. Let's go back to the I think I do need my keyboard. We might need to give me just enough space to mash some buttons. Okay, so yeah, let's do that. Let's grab the keyboard. I've got the mouse. Do I have the right view here? I think can I share my screen? Let me open up Tinkercad or the mBot first. The software for this. mLink is the software. And I'm going to open that very quickly. We're going to get to the block-based editor. And as I open that, now I'm going to see if I can share that screen. Excellent. That screen has been shared. Now let's see. Oh no. That is not the view that I want. Why? Okay, maybe not. Will I be able to share both of these? Shut up! I can share both on the same screen. That is amazing. Okay, cool. I don't know how to get rid of that other box right. Oh. We'll just make that disappear. Okay, cool. All right, cool. This worked out much better. I was expecting drama, but no drama. So let's try this. We need to add our mBot as a device. Right here. So I'm going to click on the mBot. We're going to add the mBot as the thing we're programming, the guy that we want to write stuff with. And we just want a simple program. So when the mBot starts, forever, we want to ask a question as long as the mBot is running. We want to know if the mBot sees an object closer than, less than, let's say 8 centimeters. Let me zoom in on that because that is terrible. There we go. Hopefully Zoom and Twitch and everywhere can see that. But so whenever the robot is on, it's like we turn power on. So forever, as long as the power is on, it's going to ask if it sees an object within 8 centimeters in front of it. Just like that. If the answer is yes, it's going to turn lights on red. Actually, it's going to turn lights on green. Green for go. Green for good. Excellent. If the answer is not yes, or if the answer is else, all the lights will turn on red. Okay, so that's our code. That's what we're gonna do. That's how we're gonna work with this. Excellent, super cool. That should be super easy. Now we're gonna plug these robots in and get them going. And this is the test that we're gonna run. So I'm gonna start with the robot that I broke out of the box last. We're gonna plug him in, connect. Here we go. That looks like it says COM6. We're connecting. Connected. We're going to upload this code right to our robot. You can see processing. You can see Arduino server connected compiled because this is an Arduino based robot. So there's actually code in here. If you wanted to see the code, you could pull this aside and you can see this is the actual like Arduino code. You could learn like what blocks do what. And you could see there's a block here that says while. It's really small, but the while block is the forever code. The while command is the forever we're going to do stuff. Then you'll see the if right here is the if statement, and then down here is else, and then you'll see the while, and the other end of the while at the bottom is this thing called, says loop. So while loop, it's going to do this forever loop right here. So you can kind of like learn the code if you wanted to like try to piece it together and don't know the code. Cool. But that's how you can kind of figure out and learn some of the code that you don't know yet. All right, we're gonna plug in the robot we just built, and this guy will. I will show this in just a second. But there is a red light on that is charging the battery, the USB battery. That is excellent. That is what we wanted to do. So we're gonna upload this code to this robot, and for my Zoom team. The red light right there is showing that this is charging. And I don't know if it changes to green or if it just turns off, but the red light is right here next to the 3.7 volt battery that's plugged in. It's very cool. And you can see my hands here are actually like changing the sensors. So it's definitely like green because my hands are in the way. But I'm going to turn these off. We're going to get these facing each other and set up so that we can see what's happening. I'm gonna coil up some cords and get the cords out of the way. Then we're gonna run a test. All right. Let me get the keyboard out of the way. I think we're done with the code for that part of it. I'm gonna stop sharing my screen in Zoom, and we're gonna switch to the actual Zoom view from Chrome. Oh, right there. Excellent. Excellent. Yes. Okay, cool. So we've got these two robots. Let's get them set up. So here's what we want to do. We want to find out how far apart they can go. So 8 centimeters between the two of them. I'm going to break out the digital caliper right here. We're actually going to measure the 8 centimeters. That is 80 millimeters right there. So that is the accurate distance. So we're going to turn these guys on. And you can see right now, 80 millimeters. Let me back them up a little bit more. Get them right in the middle of the screen here. 80 millimeters from board to board. That is definitely enough space. And they are not interacting with each other right here. But you can see now, this one's turned green because he thinks he sees something within 80 millimeters. They're still not within 80 millimeters though. So they're not within 8 centimeters yet. But I mean, they might barely be just based on this part, but not from board to board. So if I do this number right there, you can kind of see. But, are we ready? I'm going to turn this one off. Ooh. Okay. Now let's turn this one off. No change. Let's turn this one on. Oh, there. You can kind of see it. This one is getting a signal from this one. So I'm gonna turn this robot off. I'm gonna turn off the All-American robot. And now it does not detect anything. If I turn on the All-American robot, it does not now. If I turn on the All-American robot again, so it does occasionally, but not consistently. So let's try the other way around. Let's back this up so that it's red right there. Oh. And this one is not interacting with the All-American robot. But I find it interesting that there's a possibility that they do, which probably means... There it goes. See it? So the frequencies might be timed in some way, and the timing might have... Like when we turn it on, might have something to do with the timing. Because now you can see the All-American robot thinks there's something there. And when we turn this switch off on the new robot, it goes back to knowing that there's nothing there. So I can stick my hand in here and see that. See that my hand is close. But I can move my hand far enough back so that there's nothing there. And it doesn't happen all the time, but it happens sporadically. So this leads me to believe that the sensors send the same signal, but aren't sending the same signal constantly, and it's all about the timing, like when we actually turn the robots on. So if I were to time this perfectly and turn them both on at the same time, one would think that, I don't know if I can do this or not with the switches. Oh, see, this one's going crazy. The new one's going crazy because he's picking up something from this one, from the All-American bot. So if I shut this guy off, it turns back off again. So the sensors do interfere with each other, but it's sporadic, and it's sporadic in a way that is like we can't prove when it's going to happen or when it's not going to happen. And that seems problematic to me for Battle of the Bots, because that means we can't rely on the distance sensors the way we wanted to. So if I, there we go. See? How weird is that? It picks up the signal intermittently and only like at random points. And if I back this up, you see me pulling away, it's still getting that signal. And we are much further than 8 centimeters at this point. So the interference is coming from the sensors as they're straight on, even as they're straight on, not even at an angle. But it doesn't happen all the time. Like right now, this is accurate. So this is still accurate. Oh, and now they're both getting jammed. So I mean, it happens like 5% of the time, maybe. But it's still enough to throw a wrench into our plans as far as whether we think our robots should be looking in front of them or looking down on the mat. And I think the answer for our robots and our battles is we have the sensor there, and we'll use it, but we might get unexpected results because of it, which is kind of wild and kind of cool. I would not have expected that to happen between these two robots. And I think the frequency that this happens, just my personal guess, the frequency that this happens has something to do with the timing of when the robot starts, and when the robot starts like this cycle of, I'm going to send this signal out every 4 seconds, and we keep turning this one on every second, every 4 seconds, every 4 times we turn it on and off, it's gonna interfere. So it's weird. It looks weird, but it's not, because it's all about like the intermittent signal. They're catching each other at certain times. But very fascinating that it works like that, and very, very cool to confirm that is the actual issue. So what does that mean for us? Honestly, I'm monkeying with robots in boxes, and I should probably stop that. As I come back to my view, and I'm wondering now if I'm gonna try a test really quick right now. I'm sharing my webcam with the stream with the Streamlabs app and Twitch, YouTube, whatever, this camera app right here, but my personal, like my webcam is not being seen in the Zoom chat. so I'm using my phone camera right here to see my desktop, but nobody in the Zoom stream can see my face while I'm talking right now. But right now, I'm going to try to turn on my video and see if I lose the ability to share that feed also with Twitch and everybody else. So I'm going to wrap this stream up with that test, because if I disappear, and you know, the stream's over, you're kind of out of luck. But what I'm going to do is explain that these robots right here that you can see, have this distance sensor on the front, and this distance sensor on the front works very well for objects like a rock or a tree. They do not work very well when they're trying to detect another robot with another sensor, because the sensors are using a frequency. They're using that like 4 gigahertz or 5 gigahertz or whatever. Actually, I think it's lower for the ultrasonic sensor, but actually it's a lot lower for the ultrasonic sensor. I want to say like maybe megahertz, probably kilohertz, but anyway, that frequency is the same between the robots, and the only difference is when they send the signal out to see how many like what's in front of them. They're doing it on an interval. It's not constantly being blasted, otherwise they would never know like how long it takes to come back. And that gap, that space between signals is probably predetermined also. It's probably like built into the code, or the hardware, not the software code, but the firmware. But it means that it happens based on when the robot turns on, not based on like the clock on your wall. So we can make these robots have a problem with their sensors if we time their power engagement at like an accurate interval. So to us, as far as the Battle of the Bots is concerned, we just need to know that when our robots are facing each other in any way, there's a very good chance that the distance sensors won't be accurate. And we've encountered this over the last couple of weeks, and we've changed our code to actually match that. So it's kind of cool to do that. But excuse me, we have not used these mBots to do this yet. So the mBots, we were also using the lines on the tables, and we'll get into that on Saturday. But it was also a bit of code involved in the I want to do different moves if I'm close to the bad guy, because I want to push the bad guy off the line, and I want to be the winner. And that's going to be a challenge, because there'll just be some inaccuracies, and that's why it's going to be our kind of like easy level, not a big deal. And this is much more fun to do with a maze. Maybe maybe we ditch the sumo battle and go to like a maze kind of event where we can see the mBots, and that leads us to other ideas and other things. If you look at this robot, if we do a maze, if we set up a maze, we will have certain needs for the maze. Like we have to see the robot in the maze, so the maze has to be so tall, which means that we probably need to design a new mount for these robots so that we can have a short maze. Maybe our maze for this robot is not very tall. Maybe it's very, very short, and that will enable us to put a camera over it so that we can see the robot moving through. But these are just ideas and things. When I do this in person, the maze is like a foot tall, so it looks very intimidating. And as we adapt this to online, there'll be changes and different needs for that situation. But I'm going to disappear right now, and in disappearing off the streams and things, I'm just going to share my screen or start my video in our Zoom chat. So if for the rest of anyone who catches the end of this, goodbye, good night, thank you, and see you Saturday. Cannot start video. Failed to start video camera. Select another video camera. I actually have a second camera. This is what I was gonna surprise the plan with this, but I got a second camera to be able to do more than one thing. So I did not disappear from Twitch or YouTube or anywhere else. I am not allowed to start the camera in Zoom because Streamlabs is hogging it. All right, good to know. But we're gonna wrap up the stream.